take a look at a quick review here of what we did. A few days ago we learned what a geometric sequence is. A geometric sequence is a sequence of numbers where there's what we call a common ratio. We're going to review the whole unit today, but the common ratio is what you multiply a term by to move forward in the sequence to the next term. The common ratio can always be found by dividing a term by the term before it. Lots of ways you can talk about the fact that a sequence is geometric or not. However, when we talk about a series, of course, is the sum of the terms of the sequence, and we have these two formulas. Briefly, Sn is the sum of n terms, so as soon as you load in n equals, say, 5, you're finding the sum of the first 5 terms. T1 is the first term, obviously. R is the common ratio. N is how many terms that you're adding together. And then in the second formula, there's that Tn, and the Tn has a very special meaning when you're talking about series. For any series, arithmetic or geometric, Tn is the last term. It's the value of the last term. Okay. The somewhat nice thing about these formulas, particularly when it comes to this top formula and finding n, is that you don't have to, there's no pressure to solve this algebraically. A lot of the problems you can only solve on your calculator by going to your table. So with that being said, I'm going to start off with question 9 because somebody had asked about number 9. A fan-out system is used to contact a large group of people. There was a time before email, before your time, before everybody had email, where, for example, if the school was closed, we used to close the school if the roads were very bad, that the principal would be notified that the school was closed, and the principal would phone 4 people on, we called it a fan-out list. Everybody had at home a sheet of paper, and it said, Mrs. Elgert at the top, and then it had 4 lines going from her to Mr. Wilmot, Mr. Myers, Mr. Way, Mrs. McFeely. And then Mrs. McFeely phoned 4 people, and Mr. Wilmot phoned 4 people, and it spread out that way. It's what's called a fan-out system. So the person in charge of the contact committee relays the information to 4 people. Each of these 4 people notifies 4 more people, who each notify 4 more people, and it continues. Write the corresponding series for the number of people contacted. Now, we have a little bit of an issue here, and it's kind of like that bouncing ball, which is that the first person, the committee head, I don't consider them to be a person who's contacted. Okay? The person in charge relays the message to 4 people. In my mind, and this is a little ambiguous, which means I can see how you would interpret it differently. In my mind, that person is the boss, and he or she has not been contacted by anyone. They're the person who decides on the decision. So in my mind, the first term is 4. It's the 4 people. Let's call the boss, the boss. That first person is the boss. The boss contacts 4 people. Each of those 4 people, think about this for a second. Here's the boss, and they contact 1, 2, 3, 4 people. So there's 4 in this list, right? But each of those 4 people contact 4 people. Which means in the next layer, there's 16. And I think you can start to see why this is going to have a common ratio of 4. Because each person contacts 4 people. So one person contacts 4. 4 people contact 16, etc. This is the sequence we're dealing with here. How's my math? 4, 16, 64. Okay. That's the corresponding sequence. This question is maybe a little bit ambiguous as well because maybe they're after the general term. The general term would be, and I want to talk about this one a little bit, for A, the general term for geometric is the first term multiplied by the common ratio to the n minus 1. The first term is 4. The common ratio is 4. So this is the general term. However, it can also be written this way. And this came up in our lesson on geometric patterns. I can't remember the exact type of question, but it doesn't matter. 4 is 4 to the 1. So up here what you have is this 4 to the 1 being multiplied by 4 to the n minus 1. And I will remind you that when you have a base raised to an exponent multiplied by another power with the same base and another exponent, you can add the exponents together. The base remains the same, and you add the exponents. That's why, for example, x squared times x cubed is x to the 5. And you know me, yeah, I'm about teaching sequences and series, but right now I'm about teaching math. This is an important math idea. So I get this t sub n equals 4 to the n by taking these two powers and adding the exponents. And 1 plus n minus 1, 1 minus 1 is 0, so we're left with 4 to the n. So that's A. Now in B, and I'll be honest, I don't know if the textbook interpreted the question that way. If they didn't, then they would have 1 times 4 to the n minus 1, because they would be including the boss as somebody who's contacted. Is that what they did? They showed both. Well, that's interesting. That's actually very good, because then when you look at the back, you can go, oh, it depends on which way I look at it. I'm going to show you a review question that will be in the review package I give you today that makes it totally unambiguous. It makes it perfectly clear which one we're after. How many people are notified after 10 levels? So if they showed both, did they have two answers for part B? They did, eh? Okay. So I'm going to go with my assumption that the boss is not contacted. Okay? And I'm going to figure out how many people were contacted at 10 levels. And then we can talk about what if the boss was one of the levels. We would want to find S10. I'm using right now this formula. I'll write it down up here. Sn equals T1 times r to the n, then minus 1 over r minus 1. How did I do on memorizing that formula? Have I got it? Is that it? Okay. So S10 would be the first term, which we said was 4, times the common ratio, which is 4, raised to the 10, then minus 1, over 4 minus 1. And you know, there does come a time where you have to be able to know how to use your calculator properly in order to get answers. Okay, you need to know how to do this. I'm, as they say, old school. I would probably just say 4 raised to the 10, even though I know I don't need to do it this way. I still do it. Then I go, and that's a lot of people. Wow, we still have to do some other things. I subtracted 1, I multiplied by 4, and now I need to divide by 3. So the number of people contacted, if we don't consider the boss to be a person who's contacted, the number of people contacted is that after 10 levels. But we have another problem here, and I really don't like the way this question is worded. Because if you say this is the sequence, which is the second option in the back, I'm assuming, then t sub n is 1 times 4 to the n minus 1. So this is the boss as being somebody who's contacted. Okay? But then, what does it mean to say, look at the words here, after 10 levels? Do you consider the boss to be a level? I don't know. So in my mind, and I'm feeling the textbook and I are going to diverge away from each other on this, in my mind, you would be finding S11 here. And what you would discover is it would be the answer we got using 4 as the first term plus 1, the boss. I don't consider the boss to be a level. Even if we consider him to be contacted, I consider a level to be going from one to the other. So it's very ambiguous here. And if you were to take a look at a question, just let me find it. There it is. If you were to take a look at a particular question, there we go, that's going to be on your review handout that you'll get a little bit later today. Fred starts a rumor by telling two of his friends something he heard. Fred was told a rumor. He told 2 friends. Those 2 friends each told 2 friends, etc. Every time a person hears the rumor, they tell 2 more people who have not heard the rumor. And the question, look at this, including Fred. The number of people that have heard the rumor after it has been passed on 12 times. Okay. Fred has to be included. But I consider this, when it says passed on 12 times, to say what's S13. It hasn't been passed on to Fred directly in this question. It has somehow, but I don't consider it that way. And now that I look at this question in even more detail, I think I could clean it up even more. But on an exam, it wouldn't be ambiguous at all. And if a question like this, I think maybe this might even still be a little ambiguous. Some of you might find S12 and some might find S13. I would accept both answers. Anyway, is that okay? Okay, other questions that people might have from the assigned problems. Go ahead, Ashira.
Question
8? So what is the second term of a geometric series in which the third term has a value and the sixth term has a value? You're going to see on the review handout that there's a lot of... You're going to see on the review handout that there's a lot of questions that are like, wow, I've never seen that question before. But most of them boil down to the same idea, which is, what are the parameters that define the sequence? Because if you know that, you can find the sum of any number of terms, you can find any term. So what's important here is this is geometric, and we need to find the first term and the common ratio. And ultimately, you know, this is just like the second question on the assignment that you've turned in. I'm going to do it with a system of equations and using the blank method. Okay, which do you prefer? The blank method. Well, we'll start with that then. There's a reason why I don't personally prefer the blank method, and that's that if I told you it was the 112th term and 140th term, you're going to be spending a lot of time drawing blanks. But what we have here is the second term is 9/4. So here's the first term. The second term is 9/4. Then we have the third term, which we don't know, the fourth term, which we don't know, the fifth term, which we don't know. The sixth term is negative 1681. I don't know if this is obvious to you or to anybody. I think it's obvious to some of you. Anytime you have a geometric sequence or series, and some of the terms are positive and some are negative, you have to have a negative common ratio. Did I not write it down correctly?
The 9/4 is supposed to be the third term, not the second term.
Oh, it's the third term. Gotcha. Does that summarize it? Okay. So the idea here behind this method is that to go from here to here, you multiply by r. To go from here to here, you multiply by r. To go from here to here, you multiply by r. And by the way, there's a similar kind of approach with arithmetic, but this is very useful in a lot of questions because quite often you're told two terms and they're not next to each other. If they were next to each other, we could find the common ratio or the common difference if it was arithmetic, but they're not. So what this is saying is that if I take 9/4 and I multiply by r, and I multiply by r, and I multiply by r, I don't like saying I multiply by r 3 times. There's nothing wrong with it, but when I say that, some people think I mean you multiply by 3r, and that's not what I mean. You multiply by r times r times r to get negative 16 over 81. So I get 9/4 times r cubed equals negative 16 over 81. Let's talk about this equation in terms of the math of the equation. Although you don't need to do what I'm going to describe, I'm going to describe it anyway because you will need to do what I'm going to describe later on where equations get more complicated. I know you could use kind of a concept of cross multiplication. Okay? And by the way, how many of you have been taught that the fish thing? Okay, you know what? Stop it. Okay? It's okay for very simple equations, and if you don't know what we're talking about, that's good. It's okay for very simple numerical equations, the fish thing, where you draw the fish. But if that's what you have to lean on all of the time, you're going to run into problems later. Okay? There's nothing wrong with it sometimes, but there's a better way to approach things. The bottom line here is in any equation, whether it's an equation like this, or an equation in trigonometry, or an equation in rational expressions, we don't like fractions. We would rather not work with fractions. So I see on one side of the equation something over 4. So what I'm going to do is I'm going to multiply both sides of this equation by 4. Okay? And I'm not going to worry about crunching numbers right now. That's not the point. I'm multiplying both sides of this equation by 4. And what happens on the left-hand side is this, and I'm left with 9r cubed equals to negative 16 over 81 times 4. And again, I'm not interested in crunching that 4 times the negative 16, and I do want to point out to you where I wrote that 4. So now I've walked away from sequences and series for a while, talking about math. I did not write the 4 like that. There's nothing wrong with that, but in order to make sense of what's going on, I need to appreciate that 4 is 4 over 1. 4 is a numerator, and it's over the number 1. And then I look at this and I go, you know what? I still have a denominator, this time on the right-hand side, so I'm going to multiply both sides by 81. And I end up with 81 times 9 times r cubed equals negative 16 times 4. These 81s cancel. And, again, I'm perfectly aware that many of you can go from the red equation in here to this in a blink of an eye. Okay, I get that. But I want to point out to you why what you're getting in the blink of an eye is correct. You're multiplying both sides by the denominators to remove the denominators. Now, ultimately, now we can simplify this. 81 times 9, I think, is 729. But you can verify that for me. It is. It's times r cubed. Negative 16 times 4 is negative 64. So I divide both sides by 729 and get r cubed equals negative 64 over 729. And now I can take the cube root. Now, keep something in mind here. We need to know the first term and the common ratio. This will just give us the common ratio. We still have some work to do to find the first term. But I take the cube root of both sides. We will learn later in this course more about radicals and square roots and cube roots and all that. But I'm telling you that, Take the cube root, I'm just left with r. I'm telling you that when you take the cube root of a fraction, that's the same as taking the cube root of the numerator over the cube root of the denominator. And I'm going to challenge each and every one of you right now. You can use your calculator, but I don't want you using the cube root function, to find out what the cube root of negative 64 is. It's the number that when you multiply it by itself 3 times gives you negative 64. So it's got to be a negative number. What number cubed gives you 64? 4. Sure. And I'm not, preventing you from using your calculator and going cube root of negative 64, but I'm getting you to think. What number cubed gives you 729? I don't think, is there one? No, there is. What is it? 9. 9 times 9 times 9 is 729. So what that means, you would ask the question, right? Okay. What that means is we now know the common ratio is negative 4 nines. Okay. Now, what do we do from here? This is actually a nice little 3-mark written response question. We'll talk more about the exam tomorrow and a little bit today, but this will be a nice 3-mark written response question. And you would have to show your work. So everything that I've done here, you would have to show that somehow. Okay? There's really no explanation here except for perhaps maybe a brief sentence describing this times r times r times r. Okay? But the algebra speaks for itself. So, what now? Well, we still need to find the first term. So we go into the second phase of this, and we say that I have lots of information available to me, but I need your help here. I think the third term and the sixth term were the terms that we knew. And I'd better just look up because I can't remember them. 9 quarters and negative 16 81sts. We also know that Tn is the first term times r to the n minus 1, and we know r. So we can put r in to that general term and get t sub n equals the first term times r, which is negative 4 over 9, raised to the n minus 1. And we have, everybody, a missing parameter, right? You don't know T1. I'm aware, and I think you're aware, that we could find the first term by just taking 9 quarters and dividing by the common ratio to get the second, and then dividing that by the common ratio to get the first. But I'm showing you an algebraic method. So I'm going to put in for n 3. This is actually not a very quick, simple question. Not if you're going to do it on paper. And for Tn, I'm going to put 9 quarters. I could use the other point instead, but the numbers are bigger and one's negative. So I get 9 quarters equals T1 times negative 4 over 9 raised to the 3 minus 1. Three minus 1 is 2, and now I'm admittedly showing a lot of extra steps here that I don't know that you would need to show. Well, I guess you need to show them, but let me finish writing this down and then tell you what I'm trying to say. I think if you were just doing this on your own, you probably don't need to show all these steps. You could have just written to the 2. Well, let's simplify that. Is there a simpler way to write negative 4 over 9 in brackets squared? Yes. I square the negative 4 and get 16. I square the 9 and get 81. So I get T1 multiplied by 16 over 81 equals 9 over 4. We're kind of at the same kind of stage we were at earlier, where I'm going to multiply both sides by numbers in order to get rid of denominators. I did that, and I think it was up here. Remember that? To point out to you that's what's happening but I don't think we need to do it all the time. Here, I think it's pretty easy to see. You're just going to have 9 times 81 equals T1 times 16 times 4. You know, if you multiply both sides by 4, the 4 on the left cancels and you're left with 4 on the right at the top. And if you multiply both sides by 81, the 81 on the right cancels and you're left with 81 on the top. We can divide now and you get, and this is a bit of a coincidence. It's a total coincidence, okay? Don't worry that we've seen those numbers again or before. That's the first term, 729 over 64. Okay. What are we asked to find? Well, thankfully, we're given permission to use decimals now. We're asked to find S6. And I'm just going to erase this so I have some room to put it up here. I'm using Sn equals T1 times r to the n minus 1 over r minus 1. I'm going to use this information along with n equals 6 to get S6. The first term, 729 over 64. And I think, you know what, the rest of my explanation here is going to revolve around how to enter this into your calculator properly, because it's going to be a mess. R to the n, well, r is negative 4 over 9 raised to the n, which is 6. Then I need to subtract 1, and, you know, make a note that those brackets are there. And then I need to divide by, my goodness, r, which is negative 4 over 9 minus 1. Wow. So we need to figure out what that is equal to. And by the way, forgetting about this question, when you go 5 raised to the 6, how many of your calculators show that? As opposed to it puts the 6 up top. Okay, I hate that. I hate it when it puts the 6 up top. You know why? Because you start typing and it pushes stuff off the screen and you can't see what you've written. Okay, just a word of advice. If your calculator is in that mode, let's say it's that one. Nope. I opened the same one, I guess. Yeah, there we go. Interesting. Oh, there we go. There we go. Okay. If your calculator is in that mode where this happens, and you start typing, do you know what I mean by it pushes stuff off the screen? That can be a problem sometimes if you're entering lots of stuff, because then you can't look at what you've entered. If you ever want to get out of that mode and go to what they call the classic mode like this, has anybody got a TI-84? Is your resolution that small? It's bigger than that, isn't it? Okay. I'm going to go with this one. There's something wrong with that. So if this is what it does, there's a way to get out of that mode into what's called classic mode if you ever need to. You go to Format, which is you go Mode, and you scroll all the way down until you see Math Print and Classic. And if you go Classic, you're in that other mode. I like this other mode as well because I don't usually look at the screen while I'm entering stuff. How many of you have entered stuff and there's an exponent and then you look up and it's like you've entered all that stuff in the exponent? It's problematic there too. Anyway, I'm going to show you how I would do this, even if I did it with a scientific calculator. I would go in brackets, negative 4 divided by 9, n brackets raised to the 6, and I would go equals. Then I would subtract 1, and I would go equals. I would multiply by, now the brackets around the 729 over 64 are not necessary, but I'm going to put them anyway. Okay. And then I would go equals, and then I have to divide by negative 4/9 minus 1, so divided by in brackets, negative 4 over 9 minus 1, close brackets. And it's at this point in time where I'm going to look at everything I've entered just before I hit equals. That looks okay, minus 1 is fine, times T1 divided by R minus 1, so I'm getting 7.8. We want to the nearest tenth, so 7.8. Long road for that question, a lot of work. Other questions? Yep. 5a. So what is the value of the first term? Well, we have, sorry, if I ever forget to unfreeze that, somebody let me know again. We have these two formulas that contain Sn. And I'm going to look at the formulas that have Sn here because Sn is given in A, right? Sn equals R times Tn minus T1 over R minus 1. Is that a formula? Or did I just dream that? That's a formula, right? And I have Sn equals T1 times R to the n, then minus 1 over R minus 1. And I'm pretty sure that's right. So when we take a look at A, we know Sn, we know Tn. Well, right away, I mean, I see Tn. I'm thinking the first formula I wrote because there's a Tn there. That's not to say you couldn't do it with the second formula. You just have to do some other things first. And you know the common ratio, and you're asked to find, what are we asked to find? T1. So the question is, if we use this first formula, do we know enough to find T1? Well, you know this. You know that. You know that. And you know that. You know everything in that formula except for T1. So what this question boils down to now is your math skills in how do you use an equation to find T1. And I'll be honest with you, everybody. I hope you're starting to gain more and more of an appreciation for this idea every time I talk about learning math. Not learning sequences and series, but math. I could have given you this equation and told you that A is 33, B is negative 2, C is 48, and asked you to find D last year in Math 10. It's what we've done is we've turned this equation into a math problem, not into a sequences and series problem, into just a regular math problem. So I'm going to put all those numbers in there. I'm going to have 33 equals R, which is negative 3. Most of the time I like to put things that I substitute in brackets. I think it becomes helpful. It's negative 2? Yeah. Okay. Thank you. Of course. Times T1, times Tn, which is 48. Let me get my bearing again here. 33 equals R times Tn minus T1. Now here's a tip for you. If you want, put X there. If it helps you visualize things better, you can put X over R minus 1. So now we're in the simplification mode math-wise. Are there things in this equation that can be written simpler? Well, yes. Negative 2 minus 1 is negative 3. It's simpler. Negative 2 times 48, that can be written as negative 96, I think. Okay, so we get negative 96 minus x. Oh, look at what's happened here. Look at where the problem started. It turned into using that red formula, which turned into the first brown equation, which turned into the equation that we're at now, which is a lot simpler. We're almost at a grade 7, 8 level now. I don't like fractions, so I'm going to multiply both sides by negative 3 to eliminate that denominator. And what I will get is negative 30, nope, negative 99. Keep me on my toes here and just let me know those numbers are right. Okay, negative 99 equals, now here these cancel. Negative 96 minus x. You could just solve it from this point by saying the x is negative. I'm going to move it to the other side and make it positive. And I'm going to bump the 99 out of the way by moving it to the other side. But sometimes this will happen. Every term in the equation is negative. Multiply both sides of the equation by negative 1. It just makes it easier. I don't want to work with negatives if I don't have to. I can subtract 96 from both sides now. And what we're getting is 3 is x, but that was the first term, so the answer to the question is the first term is 3. Okay. But at the same time, I recognize that sometimes students, it's not obvious what students remember. Okay, so we do need to review some things. What an arithmetic sequence is a sequence in which there is a common difference. The common difference, there's two ways to look at it, is what's added to one term to move forward to the next term, or it can be thought of as what you get when you take a term and subtract the term before it. So if I take the second minus the first term, I'll get the common difference. If I take the third minus the second, I get the common difference. If I take the 25th minus the 24th, I get the common difference. So we say generally then that the nth term minus the n minus 1th term is the common difference. That's all that means. We then learned that there's a formula. The first day we just spent working with arithmetic sequences, not even realizing that there is a formula. We did them the hard way. But there's your formula for the general term. You need to know in that formula that n is the term number, whereas Tn is the term value. And I don't think that any of you have any confusion over that anymore, but if you do, you need to clear it up before Thursday. T1 is the first term and D is the common difference. Again, just taking this opportunity to teach math and not sequences in series. These two things are different in principle than these two things. The difference is these are parameters. So for a given arithmetic sequence, it doesn't matter what term you're talking about in this formula, T1 and D have certain values, whether you're talking about calculating the 8th or the 9th term. Whereas the things I've highlighted in yellow, are variables. And even just understanding that language makes it easier for us to communicate, because then I can say things like, look, in order for you to find anything about that sequence, you need to know the parameters that define the sequence. And you need to know whether it's arithmetic or geometric. The other thing about the idea behind variables is that it connects you to this table, this concept of a table of values that you can generate on your calculator. We then learned what an arithmetic series is. An arithmetic series is simply the sum of the terms in an arithmetic sequence. So, when you talk about, I'll just jump down to S3. What does S3 mean? It means T1 plus T2 plus T3. What does T3 mean? It just means the third term. It's helpful on exam questions sometimes to note, and I'm just going to stick with S4 and S3 for this illustration, that is always going to be the case. It doesn't even have to be geometric, everybody. If you take S4 and subtract S3, you have to get the fourth term. And look at the bottom of the screen here. S3 is the sum of the first three terms. S4 is the sum of the first four terms. S4 just has an additional term added to it. And that's why the difference between S4 and S3 is that fourth term. And you're going to see lots of cases in the review and on the exam where you have to use that idea. Then we learned that there's a couple of formulas. I don't want to walk through both of these formulas, letter by letter, but you should know that S is the sum, N is how many terms you're adding, T1 is the first term, D is the common difference, and Tn is the last term. That's the added thing here. Tn is the last term. And I will point out to you that you need to know the number of terms to find the sum in arithmetic series, no matter what. And sometimes you don't know the number of terms. But you will know an ordered pair and enough information for you to find the parameters so that you can find out what value of n gives you the last term, and the value of n that gives you the last term will be the number of terms. So sometimes, even though you're working with a series, you have to go back to this formula and work on it. Geometric sequences, okay, well, this is what I mean by there's not a lot in the unit. I mean, the review is very quick. A geometric sequence is one in which there's a common ratio. A common ratio means that you are multiplying. Did I give you one of these handouts? Okay. The common ratio means that you're multiplying by that number regularly to move forward, or thinking backwards, if you take a term and you divide by the term before it, you get the common ratio. So T2 over T1 is the common ratio. T3 over T2 is the common ratio. T28 over T27 is the common ratio. Tn over Tn minus 1 is the common ratio. The formula for the general term, of course, and this is on your formula sheet. I don't know why I have that twice. This is on your formula sheet. T1 is the first term, R is the common ratio, N is the term number, and Tn is the term value. I did this for arithmetic, so I guess I'll talk about it here for geometric briefly. R and T1 are parameters. N and Tn are variables. All right? This is a variable. This is a variable. I mean, another way to look at this whole concept of variables versus parameters is to say, if I asked you to graph this sequence, your graph wouldn't be a graph showing R and T1. That doesn't even make sense. Your graph would be something that would show N and Tn. They're variables. They're changing, so you get a graph. And this is the general term, sometimes called the nth term. And then finally this, and that's it. I mean, I feel as though I don't even really want to say too much here. You have two formulas for sums of terms of geometric series. Know what all the variables, or letters, I guess I should say, in that both those formulas mean. How many of you have discovered, even though you've only been working with this for a little bit less than a day, is that coming from the hallway? It's loud, eh? How many of you have discovered, even in less than 24 hours kind of working with these formulas, that you probably use the top formula more often? Even to the point where if you could use the bottom formula, sometimes you just use the top formula anyway. The difference is the bottom formula is very handy because you don't need to know the number of terms.